All right, parent function. So this whole unit, we're just graphing a whole bunch. So we're going to switch gears a bunch and just get into graphing now. And so we're going to go through a bunch of different graphs. There's 12 different graphs here. And yeah. So the first one is a linear graph. And I'm going to go through how to graph these in class. But so this is f of x equals x. The domain, remember domain is your x values. So I want you to think left to right. So left to right, the furthest left this goes is negative infinity. Furthest right is positive infinity. Range, bottom to top, again, negative infinity to positive infinity. Now, x-intercepts, that's where it crosses the x-axis. So that's where it crosses this axis right here. And it crosses that axis at 0, 0. Y-intercept is where it crosses the y-axis, so that's the vertical axis, and again, it crosses at 0, 0. Extrema are max and mins. There is no maximum or minimum here. The only time you'll have max and mins is when it either is a point or like it's a very clearly a high point, very clearly a low point. Okay, with infinities, we don't write it. Increasing is when you're walking uphill. Decreasing is walking downhill. We've done this, so you should remember. This is increasing from negative infinity to infinity, and it's never decreasing. The end behavior, that's the as x goes to negative infinity, f of x goes to. And as x goes to infinity, f of x goes to. And as x goes to negative infinity, it goes to negative infinity. As x goes to positive infinity, it goes to positive infinity. Discontinuities. There's 3 different types. Basically, it's continuous if you can draw it without lifting your pencil. It's discontinuous if you have to lift your pencil. So I want to go through these 3 different types. This first one, this is the jump, discontinuity. That word's hard for me to say. But basically, you're going along, and then you jump and you come back up and go along again. So that's called a jump. Infinite is when you have things go into infinity along a line. So there's 3 different types right there. And then a removable is when you're drawing, but then there's just like a hole, and then you keep going. Okay? So, for this one, there's no discontinuities, it's continuous. And then even or odd. Even means it's symmetric with the y-axis. Odd means it's symmetric with the origin. So even functions, they act like a mirror. So they're symmetric right here. Odd functions are symmetric right here. So then you could flip this and you'd get the same image. Okay. So this one is not even, because if we were to reflect over that, you would get this. And that's not the same function. Let's see if it's odd. So if you rotate this 180 degrees, that looks like the same function, so then it is odd. Okay, absolute value, this is f of x equals absolute value of x. Domain, negative infinity to infinity. Range is 0 to infinity. It's a bracket at 0 because there's actually a point. X-intercept, 0, 0. Y-intercept, also 0, 0. This has a minimum at 0, 0. It's increasing from 0 to infinity, decreasing negative infinity to 0. As x goes to negative infinity, f of x goes to infinity. And as x goes to infinity, f of x goes to infinity. This is continuous. You can draw it without lifting your pencil. And then if we reflect it over that line, it reflects, so it is even, because it's symmetric with the y-axis. This stuff I wrote on the bottom, I would write that down somewhere on your notes, okay? Let's do this one, quadratic. That's f of x equals x squared. The domain here is negative infinity to infinity. Range is 0 to infinity with a bracket at 0 because there's a point. X-intercept at 0, 0. Y-intercept also at 0, 0. There's a minimum at 0, 0. This is increasing from 0 to infinity, decreasing from negative infinity to 0. As x goes to negative infinity, so the left side, it goes to positive infinity. As x goes to infinity, f of x goes to infinity. This is continuous, and if we reflect it over that line, it reflects, so it's even. Cool? This one, f of x equals x cubed, domain negative infinity to infinity, same for the range. X-intercepts and y-intercepts are both 0, 0. For the parent functions, a lot of these, the x and y-intercepts are just 0, 0. Now, the other extrema that we have is called a point of inflection. So a point of inflection is where the concavity changes. So like here, we're concave up the whole time, but then we change it to concave down. So basically, it's just a point where like you have this weird curvature happening. Like here, we start concave down, but then we have this weird curvature, and then we go up. Okay, so they're just inflection points. That's called a point of inflection when it looks like that. So here we have a point of inflection at 0, 0. This is increasing the entire time. It's never decreasing. As x goes to negative infinity, f of x also goes to negative infinity. As x goes to infinity, f of x also goes to infinity. This is continuous. And if we rotate that 180, we get the same thing. So it is symmetric with the origin, which means it's odd. Okay. Square root, so that's just f of x equals the square root of x. Domain is 0 to infinity with a bracket at 0. Same with the range. X and y intercepts are both 0, 0. There's a minimum at 0, 0. It's increasing from 0 to infinity. It's never decreasing. Now here, so since this doesn't go to negative infinity, and it only goes to 0, that's the furthest left of this graph, that means this is going to be as x goes to 0, f of x goes to, this would also be 0. And then as x goes to infinity, so the right side right here, f of x also goes to infinity. So that's going to be 0 and infinity. Okay, this is continuous, and it's not even or odd. Because if you flip it, not the same thing. Rotate it, not the same thing. Square or cube root, so f of x equals the cube root of x. Domain is negative infinity to infinity. Range is also negative infinity to infinity. X and y intercepts are 0, 0. Extrema, there's that point of inflection again at 0, 0. This is increasing the whole time, never decreasing. As x goes to negative infinity, f of x also goes to negative infinity. And as x goes to infinity, f of x goes to infinity. This is continuous, and if we rotate it, you get the same thing, so it is odd. This one, reciprocal, so that's 1 over x. The domain here is negative infinity to 0, and then 0 to infinity. Same with the range, because there's no points right here. Whoops, I drew that really bad. There's no points right here, and there's no points right there. The x-intercept, there's none. Y-intercept, there's none. Extrema, none. This is never never increasing. It's decreasing from negative infinity to 0, and then 0 to infinity. As x goes to negative infinity, so the left side of this, that's approaching 0. As it goes to positive infinity, that's approaching 0, so they're both 0. We do have a discontinuity on this, and it'd be the infinite one, because they're both approaching infinity. They're just, so, but you have to lift your pencil to draw it, okay? And then if we rotate this, you get the same looking graph, so that is odd. Exponential, so that's going to be f of x equals 2 to the x. Domain is negative infinity to infinity. Range is 0 to infinity without a bracket because it's never going to hit that. There are no x-intercepts. The y-intercept is 0, 1. No extrema. It's always increasing, never decreasing. Then as x goes to negative infinity, f of x is approaching 0. So the left side of this, as x goes to infinity, the right side's approaching infinity. This is never discontinuous, so it's continuous, and it's not even or odd. Logarithmic, so f of x equals log of x. We're going to get more into these graphs later. That's 0 to infinity, negative infinity to infinity for the range. X-intercept is 1, 0. Y-intercept, there isn't one. There's no extrema. This is increasing from 0 to infinity. It's never decreasing. the end behavior here. So the left side of that is only going to 0. So that's going to be as x goes to 0, f of x goes to negative infinity. As x goes to infinity, f of x goes to infinity. This is continuous, and it's not even or odd. Okay, greatest integer. So this is f of x equals, and those are like brackets of x. This is called, the other thing that this is called is the step function, because they look like steps. Okay, super creative. The domain here is negative infinity to infinity, because even though we have these open circles, it jumps up to a closed circle every time. Open circle, closed circle, open, closed, open, closed, open, closed, open, closed. So we have points all along this graph. The range here is every integer. So integers are just -1, 0, 1, 2, 3, 4, 5, and all into the negatives. The way you write that mathematically is y, this line means such that y, and then exists, this means exists, and then that weird z thing, whoops, that weird z thing means integers. Not super important that you remember that, but it's kind of good to see. X-intercepts, this crosses the x-axis from 0 to 1. There's just not a point at 1. So x is greater than or equal to 0 and less than 1. And then 0. Y-intercept is 0, 0. No extrema, no increasing, no decreasing, because there's nowhere that you're walking uphill. You're just walking flat and then you jump. Flat and then you jump. As x goes to negative infinity, f of x also goes to negative infinity. Positive infinity, positive infinity. There's a jump at every integer, so it is discontinuous, and this is not even or odd. Okay? And then we're going to skip sine and cosine, just because we have a whole trig unit coming up later, so we'll do those later. Thank you for watching. You guys are the best. All right, goodbye.